So let's take a look at the p-test with integrals. So the p-test is basically a basic test for convergence or divergence, and it says that whenever you have the integral from 1 to infinity of 1 over x raised to an exponent p dx, if p, or that exponent value, is less than or equal to 1, then the function will diverge to infinity. And if p is greater than 1, then the function will converge to a certain value, and that certain value is going to be 1 over p minus 1. So looking at number 1, where it has the integral from 1 to infinity of 1 over x to the 7.3 power dx, I can look at the exponent here, and we have 7.3, and obviously 7.3 is greater than 1. So that's how we can tell the series will converge. Now, to what specific value? Well, we have to use this equation here, 1 over p minus 1. So I can just do 1 over 7.3, which is the p value, or the exponent value, minus 1. 7.3 minus 1 is 6.3. If I were to further evaluate this, we have 1 over 6.3 as a fraction. Well, I can just say 63 over 10. And if we're dividing by 63 over 10, we're obviously going to multiply by the reciprocal, 10 over 63. And that leads me to the final answer of 10 over 63. So looking at number 2, we have the integral from 1 to infinity of x to the negative 11 over 10 power dx. So we need to be able to change this so that it looks more like 1 over x to the p. So in order to do that, we obviously have x to a negative exponent. So whenever we have a negative exponent, we can move that to the denominator. So if I were to change this equation, it could look like 1 to infinity, the integral from 1 to infinity of 1 over x to the 11 over 10 power dx. And now I can test for convergence or divergence. The fraction over here, or the exponent, is 11 over 10, and 11 over 10 as a decimal is 1.1. 1.1 is obviously greater than 1, so the function will converge to a specific value. And so we can use this formula once again, 1 over p minus 1, to find out what value it converges to. So we have 1 over, p is obviously 1.1, so 1.1 minus 1. 1.1 minus 1 is 0.1, and I can change 0.1 to be, in fraction form, 1 over 10. Dividing by 1 over 10 is the same thing by multiplying by 10 over 1, or 10. And 1 times 10 is 10. So looking at number 3, the fifth root of x to the negative 2nd power. So once again, this is not in the proper form of 1 over x to a certain power, so we need to change that. And in order to change that, I'm going to first put it in exponent form. So we can put the integral from 1 to infinity. Now whenever we put it in exponent form, the power is going to be in the numerator and the root is the denominator. So I can say the integral from 1 to infinity of x to the negative 2/5 power dx. And since this is a negative, we can move it down to the denominator and put it in the form of 1 over x to a certain power. So we get the integral from 1 to infinity of 1 over x to the 2/5 dx. 2/5 as a decimal is 0.4. And 0.4 is obviously less than or equal to 1. So we know if p is less than or equal to 1, the function will diverge to infinity.